You know, when we think about hospitals, we think of them as places of healing, right? But there's a massive challenge that lurks within those very walls: healthcare-associated infections, or HCAIs. It's this complex, ongoing problem that's really become a major battlefront in modern medicine. So let's dive into this silent epidemic.
To really get a sense of the scale here, let's just start with one number. According to a 2023 report from the UK Health Security Agency, a staggering 7.6% of patients in the UK have at least one healthcare-associated infection. Think about that. That's nearly 1 in every 13 patients. It's an epidemic that's happening in plain sight. So, what exactly is an HCAI? Well, the definition is absolutely key here. An HCAI, which you'll also hear called a nosocomial infection, is an infection that a patient gets while they're receiving medical care. It's not why they went to the hospital in the first place, but it could be a really dangerous complication they leave with. All right, so to really understand this challenge, we've got to look at the numbers and get to know the actual culprits behind this silent epidemic. This slide really breaks it all down for us. If we look at the different types of HCAIs, you can see that pneumonia and other respiratory infections are actually the most common, making up 31%. Now, what's really interesting is when you look at the bugs causing these infections, you see the usual gram-positive suspects like Staphylococcus aureus, but the most frequently reported microorganism? It's actually the gram-negative E. coli.
And look, this is not just a UK problem, not by a long shot. While our rate is 7.6%, you hop over to the US, and the CDC reports that on any given day, about 1 in 31 hospital patients has an HCAI. And if you look across the EU as a whole, that adds up to over 3.5 million cases every single year. This is a massive global health challenge.
So this obviously begs the question, where are all these infections actually coming from? Let's trace these pathogens back to their source.
And this diagram just illustrates the complexity perfectly. It's not one single thing. You can see this wheel of sources shows that pathogens can come from pretty much anywhere. From hospital staff, surgical procedures, the air itself, medical devices like catheters, and even from the patient's own normal flora. The hospital environment itself is just this huge reservoir of potential threats.
So from a microbiology perspective, we can really sort these sources into two main buckets. You have your exogenous sources, which are external, so coming from another patient or a contaminated bit of equipment. But then you have endogenous sources, which are internal. These actually come from the patient's own microbiome, when our own commensal organisms, which are usually totally harmless, end up in the wrong place at the wrong time.
Okay, now for the fun part. Let's open up our HCAI case files and really unpack the specific molecular mechanisms that make these pathogens so incredibly successful in a healthcare setting.
Our first case file, the catheter-associated urinary tract infection, or CAUTI as you'll hear it called. These are unbelievably common, and the number one offender in about 65% of cases is uropathogenic Escherichia coli, or UPEC.
So how on earth does UPEC do it? Well, it is an absolute master of building biofilms. It all starts with adhesion, where it uses the FimH protein on its type 1 fimbriae to just latch onto bladder epithelial cells. Then, the bacteria start to aggregate into microcolonies. But the really critical step is maturation. This is where they secrete a protective extracellular matrix, a shield really, made of things like curly fibers and cellulose. It protects them from antibiotics, it protects them from immune cells, and from that fortress, they can then disperse to colonize new areas. It is a brilliant and frankly a very dangerous survival strategy.
Next up, we have an incredibly serious complication: central line-associated bloodstream infections, or CLABSIs. Now, these catheters go deep into major veins. They can stay in for months, and they basically provide a direct highway for pathogens like Staphylococcus aureus to get straight into the bloodstream.
Which, from a microbiology standpoint, poses a really fascinating question. How does a bacterium even survive in human blood? I mean, think about it. It's an incredibly hostile environment. It's low in free iron, it's packed with immune cells, and it's got powerful physical forces. So how do they do it?
Well, Staph aureus comes prepared. It has this incredible toolkit for evading our immune system. It secretes toxins that just lyse immune cells. It can actively inhibit every single step of the complement cascade. It produces proteins like the famous protein A to stop antibodies from binding, and to get around that iron problem, it just pops open red blood cells to get at their heme. This arsenal of weapons makes it an absolutely formidable bloodstream pathogen. And for our final case file, a classic example of an endogenous infection, Clostridioides difficile. Now, C. diff is often just a harmless resident of our gut, but when broad-spectrum antibiotics come in and wipe out all of the competition in the microbiome, C. diff can overgrow and cause this severe, awful, relapsing diarrhea. This is literally the patient's own flora turning against them.
Okay, so this all sounds pretty grim, I know, but the fight against HCAIs is evolving. So let's look at some of the really innovative interventions that are being developed to try and turn the tide.
Remember those biofilms we were just talking about? Well, what if the catheter itself could fight back? There's some really cool research showing that specific wavelengths of violet and blue light can massively reduce the survival of E. coli on catheter models. It's a completely non-antibiotic approach to preventing the infection right at the source. Now for surgical site infections, early detection is everything. So imagine a smart wound dressing that literally changes color at the first sign of a bacterial infection. This would mean clinicians could start treatment immediately without having to rip off the dressing and disturb that delicate healing process underneath.
And to fight an ecological problem like C. diff, you need an ecological solution. Enter fecal microbiota transplants, or FMT. It's a highly regulated procedure that's used to restore a healthy, diverse gut microbiome. By reintroducing this complex community of beneficial bacteria, you effectively outcompete C. diff for space and resources. It's basically hitting a reset button on the entire gut ecosystem.
And this brings us to one final, really critical question. The massive specter of antimicrobial resistance is looming over every single thing we've talked about. So as our traditional antibiotics become less and less effective, will these innovative, non-traditional approaches, things like light-based therapies, smart diagnostics, and ecological restorations, stop being cutting edge and actually become our new first line of defense against these silent infections?